So our next presentation is from Richard Zhang from the University of California, Berkeley.
Okay, thank you. So I'm currently a research scientist at Adobe Research, and this was work done at UC Berkeley. So deep networks are extremely adept at mapping noisy, high-dimensional signals to clean, low-dimensional outputs. But graphics tasks require high-dimensional outputs. This thesis investigates a number of image-to-image translation problems. We first start off with the problem of image colorization. So we train a deep network to predict the color channels from a grayscale channel. Then, by concatenating the input and the output, we hope to achieve a vibrant and realistic colorization of the image. Here's an example of our system on this iconic photograph of Yosemite Valley Bridge by Ansel Adams. Now, a fundamental challenge in colorization is the inherent ambiguity. For example, this is a photo of my grandparents. We know the color of my grandmother's skin, but we're unsure of her shirt and of the background. A given grayscale photograph can map to many plausible color photographs. The space is actually very large and combinatoric in nature. As such, we develop an interface for user-assisted colorization. On the left, the user provides a grayscale image along with color guidance techniques. Now on the right, a deep network maps this to a colorized photograph. With just a few clicks, a user can come in and quickly and efficiently explore the space of possible colorizations. Our system can be easily retooled to take in global color histograms instead, allowing color transfer, and a completely different way of exploring the multimodal output space. Next, we investigate the more general problem of image-to-image translation. Many of these problems are multimodal in nature as well. For example, given this label map, what might a corresponding facade look like? The previous state-of-the-art method, pix-to-pix, can synthesize a single realistic result. However, you can imagine that there are many facades that could correspond to this label map. Our system, BicycleGAN, can synthesize many facades with different colors, textures, and structures. It's also a general system, so we can also take this edge map and translate it to different shoes, or imagine what this night image might look like in the day. But how does one actually evaluate how perceptually realistic the results look? For example, here, which patch looks more similar to the one in the middle? The patch on the left or the right? While most humans choose the one on the right, traditional metrics such as PSNR and SSIM choose the one on the left. We find, surprisingly, that deep feature spaces, both supervised, self-supervised, and unsupervised alike, tend to agree more often with humans. In summary, this thesis investigates the use of deep networks for graphics tasks. In solving the seemingly boutique task of colorization, we find that we actually make unexpected progress in more fundamental problems in machine learning and graphics, namely unsupervised learning, as well as predicting human perceptual judgments. Thank you.
My turn. So yeah, I think your presentation is very well done, organized, and the slides and stuff like that. I wish you had more time, basically, to delve into some of these things. The one question that, if you could fit it in the time, would be really comparisons with human choices. Maybe a bit more discussion on that, tables or validation issues.
Sure.
It's good.
Excellent presentation. I think you have a lot of information here. You compact it very smoothly, nicely transition from one to another. I do have a question. So what's your evaluation scores in terms of evaluating these systems that you have? Do you have a metric?
Yeah, we have a number of different kinds of evaluations. One thing that we really like is using real human judges on Amazon Mechanical Turk. So for a lot of these, we'll flash two images. One's the ground truth, another is synthesized. And we ask people to choose which one is actually the fake image. And we can do comparisons on these with our system as well as various baselines. So all these details are in papers.
So basically, you're using perceptual evaluation.
Yes.
Yeah, will be really nice to throw that in at the very end, because that will be that would just simply be a simple one with slide, and that would highlight it. It would be a really nice conclusion to an excellent presentation.
Thanks.
Yeah, I agree with everything said. One thing you may discuss in your write-up. in doing portraits, global illumination has an effect. So you're assuming kind of that the individual colorizations per feature, per face, can be done independent of global illumination. That's what most people do, but you'll notice there was some subtle shadowing. There was actually some effects even in the luminance, so you could tell that there was some global illumination happening, which is a little harder to capture. Just worth talking, it's not that I think you actually could learn global illumination, but but you'd need to have light source placement and so on. But it's just worth talking about the limitations and the assumptions when you're doing the colorization.
All right, thank you.